Hey everyone, and welcome back. Until now, our LLMs could generate text, they could explain concepts, answer questions, and even generate code, but they couldn't take action. That changes today with function calling. Function calling lets LLMs take action by invoking function. Let's say you have to fetch data from an external API, or maybe you need to run calculations or search the web. Function calling basically connects LLMs to the real world, making them truly useful. I will use tools and function calling interchangeably because they basically refer to the same thing. Then we can build agents using these same tools, and we'll see that later. But first, what is a tool? Here is the cool part. A tool is just a Python function with a decorator. That's it. Check this out. Here is our usual OpenAI client. Now, to define a tool, we just need to import the tool decorator. So, like this. Here I have defined an add function, a simple Python function that takes two inputs, A and B, and sums them. Okay? To make this function a tool, I just need to use the add decorator by just adding add tool on top of the function. What is this decorator doing? So, basically, it is telling the model that it can use this function, and also it is gathering some data from the function, like the docstring, which will be used as a description, and also the type hints. So basically, whatever I write into the docstring, this information will be passed to the LLM, to the client, so that it knows something about the tool. And also, this decorator will also take the type hinting information, so that the model knows what types and what arguments it must use for that function. For example, the model will see that this tool will need the two arguments, A and B, which can be both float or integers. Last thing we need to do is to add the tool to the client, which can be done just by providing a list of tools to the argument tools. Now we just need to invoke the client, like we always did. But this time, we need to provide the tools to the client. Here, for example, I am asking an addition because I want the model to use the add tool. And I'm also providing the add tool itself. The tools argument requires a list of tools. They are not limited to one single tool. In this case, we only have one. Now, as I told you before, response is a structured object that contains many things. If the model performs a function call, we can access it in the response object via response.functionCalls. Here's a note. The model is not actually executing the function. The model just tells us which function it called and the arguments. Let's see it in action. As you can see, we have a function call block, because as I told you in the response, everything is made of blocks. And this function call block tells us that the model used the tool with the name add, which is the name of the function, and with the arguments A100 and B25, because I asked the model to solve 100 plus 25. So everything worked correctly. As I told you before, the model is not actually executing the function. So if we want to execute this function, we need to do it ourselves. I can execute the function this way, for example. So taking the arguments of the function and then unpacking them to the add function. So I'm manually executing the function with the arguments chosen by the model. Now, if I run the code, I get the result is 125 because I've actually executed the function. This is very cool, but as you can see, it is a bit clunky. Having to execute the function manually is a bit frustrating. Also, if we add multiple tools, we also need to filter for the name of the tools, because in this case, the model told us that it used the add tool. And it only has the add tool, so we have no doubt the model is going to use the add tool. But we, for example, add another tool, we cannot just execute the add function like I did here. We also need to know which function the model invoked and then run that function. This is becoming a bit of an issue. Now, if we need to use multiple tools in a row, for example, the model needs to solve a complex problem sequentially, this is not going to scale well, because we need every time to check which function the model used and then execute that function and then go to the next step, so re-invoke the model. This is a common problem with a very clear solution, which are agents. Let's talk about agents. Up until now, we have covered clients, memory, and tools. These three are the essential building blocks for building autonomous AI agents. We are not just building a chatbot here. We are building something that is able to reason, plan, and then execute multiple steps in a row to solve complex problems. It operates independently within the boundaries you set for it. A chatbot simply responds. So this is unlike a chatbot. Because a chatbot simply responds to the user queries, it's very tied to the user interaction. While an agent is autonomous by definition. And that's a big difference. So how does an agent work? After receiving the query, it tries to reason on what to do next. So it decides, for example, what tool to use. And then the agent goes on using one or more tools sequentially or even in parallel. And after using these tools to achieve something, the agent computes a final response. This is a classic agent workflow. So how does an agent work? So first it receives the task. Then the agent reasons about what to do next and uses a tool or more to try to solve one or more problems. Then it evaluates the result of his action of the tool and repeats this cycle as many times as it's needed. This is basically the base workflow of an agent. Let's say I want my agent to be able to tell me the weather. In this case, I'm defining a getWeather tool, which will be a mock tool. This is not really fetching the weather from an API, it's just for a demonstration. So the weather tool takes location and when as input, and it will output a string telling the result. Let's say that I want an agent that is able to know the weather. In this case, I'm defining a getWeather tool, which is a simple Python function. This is a mock tool because it's not really contacting any weather service, but you can do it yourself. In this case, it's just taking my location and when information and outputting a fake weather. I want to give this tool to an agent, so the first thing I have to do is to declare the agent. First, I need to import agents from Datapizza AI. Now, I can declare my agent by just instantiating the class. In this case, we need a name, which is only for debugging purposes, a client, which the agent will use, in this case our OpenAI client, a system prompt for the agent, and then the tools. So this is the complete agent. Now we have something that is able to use the getWeather tool independently. If I ask the agent what the weather will be tomorrow in Milan, I'm expecting the agent to use the getWeather tool. So let's see. To run an agent, we need to use the agent.run method. So in this case, we use this method and pass a query. Perfect. So if I now run this code, as you can see, we have live logging from the agent. So first, the agent uses the getWeather tool, and we can see here that he's used the location argument with Milan, Italy, and then the when tomorrow, because it took the arguments from my request. And then the agent computed a final answer. So tomorrow in Milan it will be partly cloudy with a temperature of 10 degrees Celsius. So as you can see, the agent took my query, interpreted in a tool call, and then computed a final response. And all of this is really cool because we didn't tell the agent to run the tool. We just asked the agent what the weather is in Milan tomorrow. And then the agent figured out that the best way to tell this is to use the tool. So it autonomously chose the right args to pass to the tool, and then it computed a final answer. You don't need to write the logic to execute the tool function anymore. This is all done by the agent. Now let's see a more complicated example with more tools and more steps. Here I have two tools I defined for my agent. The first one is a generic calculator that is able to execute any mathematical expression. And the second one is a database access, so basically a search in a mock database. This is just a Python dictionary. But what this function does is basically taking a key as input and returning a value. In this case, we have information about the revenue of our first quarter and second quarter, and also employees, the number of employees. This is obviously a mock fake database. What I'm doing here is I'm defining the agent by defining a name, giving the client, as we saw before, and also using the system prompt to define the identity and the task of the agent. In this case, we are telling the agent that it's a business analyst and it must use tools to query database and perform calculations. And then it must conclude with a brief summary. So let's ask our agent what is the total revenue for Q1, Q2, and calculate the growth rate. As you can see, the analyst agent started the query in the database and it accessed first the Q1 revenue, which is 2.5 million, the Q2 revenue, which is 3.1 million, and then it computed the growth rate by passing to the calculator this expression. So the difference between Q1 and Q2 divided by the Q2 times 100. So it computed this mathematical function and then gave us a final answer, which is, here are the numbers, Q1 revenue, Q2 revenue, and the growth rate, which is 24%. So in this case, the agents took multiple steps to solve the problem and then giving me a final answer. Now, I want to show you one last interesting thing. If you've used a chatbot like ChatGPT or Gemini or Claude, you have seen that they are able to fetch information from the web and give you answers. Now, this is an important feature because many tasks require fresh real-world information. We can do that using Datapizza AI and nothing else. So, let's dive in. The most important part in an agent is the tools. In this case, we need a tool to be able to search the web. Luckily, Datapizza AI already provides such a tool, and this is the DuckDuckGo search tool. For those who don't know, DuckDuckGo is a search engine, and we have a tool that is able to search the web using DuckDuckGo. Let's see. Note, this tool is not provided in the base Datapizza AI package. We need to install it separately with pip. In this case, pip installed Datapizza AI tools DuckDuckGo. Once we have the tool, we can import it in our Python file. So from datapizza.tools.duckduckgo, import and the tool. Then we can provide the tool to the agent and then just invoke the agent. So for example, let's ask the agent how tall is the Duomo of Milan. Let's run this code. So as you can see, the tool performed a search with the DuckDuckGo tool, querying height of the Duomo in Milan, and it got results from the internet, and then formulated a response for me. In this case, the Duomo Milan Cathedral is about 108.5 meters, from the ground to the top of the golden Madonnina statue in the main spire. So, can you see how easy it is to build an agent that is able to search the web? You already have the tool, you have a clean interface for the agent, and you need nothing else. Alright. We have built autonomous agents that can reason and act to solve problems. We have also seen tools interface and the DuckDuckGo search tool. You can go crazy with this. You can experiment by changing the parameters of an agent, or you can use another tool, or you can use the DuckDuckGo tool, for example, in conjunction with something else. Agents are powerful, but they have their limits. In the next video, we are going to see how to solve even more complex problems using teams of agents working together. If you enjoyed this series, don't forget to drop a comment, subscribe and hit that bell. I'll see you in the next one. Bye.